today's experiment is our LDR, and LDR stands for light dependent resistance. Okay, so in this experiment we will try to understand what is LDR. So it's a special type of resistance which depends on light. Normally we know that we are having resistance, and depending upon the material we have 1 ohm resistance, 2 ohm resistance, 3 ohm and so on. But here in this we are having an LDR, and that LDR is your light dependent resistance. Okay, so it's a special type of resistance resistor which depends on light. Okay, so in this experiment what we will do, so as you see here in this experiment, this is a circuit diagram. So in this we will connect the circuit as they have given us. Okay, here we are having a battery, then this is your milliammeter to measure the current, this is your voltmeter to measure the voltage. Here we are having LDR, and then a rheostat to control the voltages and so on. This is our key and so on. Okay, and we are having a procedure, and in this what we will measure, we will change the distance. Okay, we'll change the distance, and at that distance what is the current in the milliammeter, that we will write here. Then we'll write the voltages. Okay, and then we know that R is equals to V by I. Using this formula we'll calculate R. Then D square, we have to square D value here, take log R and log D. Okay, and then we'll plot a graph of R versus D square and log R versus D, and then we'll find the slope, and from the slope we'll try to understand how this LDR works. Okay, so in this I will show you, this is our LDR which is inside this. Okay, so if you can, if it is visible, I will try to show you. Yeah, you can see. Okay, so this is your LDR, in which in this black tube we have mounted it, and here we are having a lamp. This lamp is used to change. If I increase the distance, the intensity of lamp going inside this LDR will change. Here we are having a battery of 5 volt. This is your milliammeter which is used to measure current, and here we are having DMM, which I have set it at the knob of voltage. So with this we'll measure DC voltage. Okay, so this is our entire connection. So I have connected this setup, and then you can see here I have fixed a scale on the table in a straight line. So what I will do, I will move this lamp such a way that the distance between your LDR and lamp will go on increasing. Okay, so I will start with the minimum distance, that is 15 centimeter, and then I will increase in the interval 5, 5, 5, 5 and so on. Okay, you are allowed to increase the interval of 10 centimeter also, it's up to us. So I will do it for 5, 5, 5 centimeter, and then we'll see how the voltages and your current changes. Okay, so in this experiment we'll do that. So I will just switch on the experiment here. So I have switched on the experiment. So I have adjusted the reading. Okay, we have started it. So you can see here, in the initial reading the distance is 15 centimeter. Okay, if you can see, the distance is 15 centimeter. Okay, and I have this scale. Okay, the reading for that is, this is your current which is around 7.2, it's 6, and we are having 7. So the current is 7 milliampere and the voltage is around 4.25. So what reading I have got, I will just write it down. For 15 centimeter, okay, the current is, this is your 15 centimeter, the current is 7 milliampere. Okay, and the voltage is 4.25 volt. Okay, so this is my first reading. Now what I will do, I will increase it by 5 more centimeter. So if it is 15, I will make it 20. Look at this. So I have made it 20, the distance between your LDR and your lamp, surface of a lamp. So now I will check the reading. So if you look the reading is, this is around 6, and here the voltage is around 4.34. So reading, this is around, this I have got 20 centimeter, the current has reduced to 6 milliampere, and the voltage has increased 4.34 volt. Okay, so we'll do the same thing. So if I increase the distance, you can look this, the current goes on decreasing and my voltage is slightly increasing. So I will take one more reading, I will show it to you. Suppose I have taken it around for 40 centimeter. Okay, so this is our 40 centimeter reading. So the current is around 3 milliampere and voltage is 4.62. so for 40 centimeter the current is around 3 milliampere and the voltage is 4.62. okay, so in this way we will take at least 10 reading. Okay, so 10 reading will take from this. Okay, and after taking the reading we have to plot a graph. So the graph which we have to plot is your R versus D square. So D square column is this. So from the reading I will get D square value. Okay, and then we are having a R versus D square, one graph is done. Then we are having a graph of log R versus log D. Okay, so we'll plot these two graph also, and then we'll see how your resistance and your distance are related to each other. So this is the relation. R is proportional to D square and D square is the intensity, is 1 upon intensity. Okay, so your resistance is inversely proportional to intensity. So what we will observe here, we will observe that the resistance, when we increase the resistance, your intensity will decrease. It's like this. Or if you are decreasing the intensity by moving this towards the away from the LDR, so we are decreasing the intensity on the LDR. So if you are decreasing the intensity, my value of resistance will go on increasing. Okay, so this is the relation. So intensity and resistance are inversely proportional to each other. Okay, so we can see this. So you can see, I will just show you the live reading. So if I am increasing this distance, you look at the current and resistance value, voltage value. Okay, so if I am increasing the intensity, your current is increasing and your resistance will go on decreasing like that. So this is the entire experiment. So in this, after this experiment, after taking the reading, you have to plot the graph and you have to understand the nature. Okay, so that's it from this experiment.